Hello and welcome to this video for the 2018 Level 3 Complex Numbers exam. So we're going to get straight into it. So question 1, what is the remainder when 2x cubed minus 3x squared plus 4x plus 3 is divided by x minus 2? Alright, so in this form we're going to have, let's just call this polynomial p of x. So p of x will be equal to x minus 2 times some function we don't know, we'll call it q of x, plus of the remainder that we don't know. So as we can see here, in this case, if we substitute x equals to 2, we'll get, so p of 2 will be equal to our r. So if we substitute p of 2, that will be equal to our r. Therefore, if we substitute 2 into our polynomial, we'll find our remainder. So p of 2 equals to 2 times of 2 cubed minus 3 times 2 squared plus 4 times 2 plus of 3. Alright, so 2 cubed is, okay, let's just calculate it. So 2 cubed is 8 times 2, 16 minus 3 times 4 plus 8 plus 3. We should get that r equals to 15. So our remainder is 15 in this case, and this will give us an achieved grade here. Question B, if u equals to m cis of pi over 3 and v equals to m cubed cis of 2 pi over 5, find u times v in polar form. So in polar form, if we multiply the modulus and the modulus, we'll just get the result will just be a multiplication. But if we multiply the two angles or the two arguments, we will get that the arguments should be added together. So in this case, we'll get that uv equals to m to the power of 4, because m times m cubed is m to the power of 4, cis of pi over 3 plus 2 pi over 5. Therefore, uv equals to m to the power of 4 cis of, so if we simplify this fraction, we should, so the lowest common denominator is 15, so 15 over 5 pi plus 6 pi over 15. So this will give us uv equals to m to the power of 4 cis of 11 pi over 15, and that is an achieved level question again here. Sorry, achieved. Alright, so solve the equation 2 plus square root of x equals to square root of x plus k for x in terms of k. So in this case, we'll just go straight ahead and square root of both sides, because if we for example, if we move the square root of x to the other side, then we'll get two square roots of x together and it'll become very, very difficult. So it's easier to just do this separately. So 2 plus x squared equals to x square root of x plus k squared. Okay, so in this case we'll have 2 plus square root of x squared equals to square root of x plus k squared. So in this case we'll get 2 times 2, which is 4, plus square root of x times square root of x, which is x, plus 2 times square root of x, but you need to do it twice, so plus 4 root x, and that equals to x plus k. So notice that this x and this x here on the left hand side and the right hand side, they'll cancel each other out. So we'll get that 4 plus 4 root of x equals to k. And we want to isolate the square root again, so we'll have 4 root of x equals to k minus 4. Therefore, we'll get that 4 root of x squared equals to k minus 4 squared. Therefore, we'll get that 16 of times of x equals to k minus 4 squared. Therefore, if we want x in terms of k, we'll just say that x equals to k minus 4 squared over 16. And that is our final answer in this question. And if we write it x in terms of k correctly, we'll get a merit grade. And in terms of getting an achieved grade, you cannot actually get. Alright, so question D, find the exact values of k for which the equation k times of 1 plus x squared equals to 3 minus 8x minus x squared has one repeated solution. So first things first, we're going to make everything equal to 0. So k bracket 1 plus x squared minus 3 plus 8x plus minus 3 plus 8x plus x squared equals to 0. And we're going to expand this bracket here, so k plus kx squared minus 3 plus 8x plus x squared equals to 0. And now we're going to group the like terms, so we're going to say that k plus 1 x squared plus 8x minus plus k minus 3, that equals to 0. So in this case, we can clearly see that a equals to k plus 1, b equals to 8, and c equals to k minus 3. So for one repeated root, that is your b squared minus 4ac, that equals to 0. So therefore, 64 minus 4 times of a, k plus 1, times of c, which is k minus 3, that equals to 0. So 64 minus 4 times of k squared minus 2k minus 3, that equals to 0. 64 minus 4k squared minus 8k minus 12, that equals to 0. And therefore 64 minus 4k squared plus 8k plus 12 equals to 0. Negative 4k squared plus 8k plus 76 equals to 0. And now we can solve the quadratic equation again in order to find the k values that satisfy this equation. So that's your negative b plus or minus square root of b squared minus 4ac over 2a. So if we just make this negative here into a positive, so we just times everything by negative 1, 4k squared minus 8k minus 76 equals 0. So therefore 8 plus or minus square root of 64 minus 4 times of a times of c, that equals to 0. All over 2a, which is 8. So therefore 8 divided by a is 1. So 1 plus or minus square root of, we'll calculate the square root. So 64 plus 4 times of 4 times 56 plus or minus square root of 1280 over 8. And we know that 1280 is divisible by 64. So we say 1 plus or minus square root of 64 times 20 over 8. And we can actually move the 64. So square root of 64 is 8. So we say that 1 plus or minus 8 square root of 20 over 8. Therefore, this equals to 1 plus or minus square root of 20. And that's our final answer for this question. So k equals to 1 plus or minus square root of 20. And to get this final answer here, we'll get a merit grade. To get an achieved grade, you're looking at the correct expression for the discriminant. Correct expression for the discriminant, so that's up to here. So we can get up to here, we'll get an achieved grade here. Question E. If z equals to a plus bi and z over the conjugate of z equals to c plus di, prove that c squared plus d squared equals to 1. Okay, so z equals to a plus bi. So therefore, the conjugate of z must be equal to a minus bi, okay? So therefore, we know that a plus bi over a minus bi, that's equal to this expression here, that equals to c plus di. But we won't worry about the c plus di for now. We're going to multiply by the conjugate so we can move all the imaginary terms from the denominator into the numerator, okay? So we're going to move the imaginary terms from the denominator to the numerator. So we're going to multiply by the conjugate. So a plus bi over a minus bi. The conjugate of a minus bi is a plus bi times a plus bi. This equals to a squared. A times bi, and then we're going to do it twice, so plus 2abi minus b squared. Bi times bi is positive bi squared. I squared is negative 1. Divided by a squared, and negative bi times bi is negative b squared I. Negative I squared is 1, so plus b squared here. And this is equal to c plus di. Alright, so now we're going to split these terms up into the imaginary terms and the real terms in order to find our c value and our d value. Okay, so therefore our real terms are without the I, and our imaginary terms are with the I. Okay, so a squared minus b squared over a squared plus b squared, that's our real part, and our imaginary part will be our 2ab over a squared plus b squared I. So therefore imaginary part equals to imaginary part and real part equals to real part, you know. So real part equals to real part, imaginary part equals to imaginary part. So therefore a squared minus b squared over a squared plus b squared, that equals to c, and 2ab over a squared plus b squared, that equals to d. And what we want to prove is c squared plus d squared equals to 1. So s squared minus b squared over a squared plus b squared, that squared plus 4a squared b squared over a squared plus b squared. Okay, so we're going to prove that this equals to 0. So this becomes a to the power 4 plus b to the power 4. A to the power 4 plus b to the power 4. Okay, so let's just expand this manually. So a squared minus b squared times a squared minus b squared, that equals to a to the power 4 plus b to the power 4. Okay, and that is so minus b squared a squared minus b squared a squared, so minus 2 a squared b squared over a squared plus b squared plus 4a squared b squared over a squared plus b squared squared, okay? So what we have here is a to the power 4 plus b to the power 4 plus 2a squared b squared over a squared plus b squared squared. And we can actually factorize the numerator. If we factorize the numerator, we'll get a squared plus b squared. Yes, we'll actually get the squared divided by a squared plus b squared to the power of 2. They will cancel each other out and we will get 1. And that is our QED we have as required. And that is our final answer here, which is an excellence level question. To get a merit grade, correct expression for c squared plus d squared, correct expression for a squared plus for c squared plus d squared, that is up to here, that is a merit grade. To get an achieved grade, you need a correct expression for z over conjugate of z. So that is with the real terms, okay? So that's up to here. Alright, so question 2. Complex numbers u and v are represented on the Argon diagram below. If w equals to u plus conjugate of v, show w on the Argon diagram. So let's find out what u and v are first. Alright, so as we can see, u is -2 on the real axis and 3 on the imaginary axis. U equals to -2 plus 3i. V is 4 on the real axis and 2 on the imaginary axis, so that equals to 4 plus 2i. Our conjugate of v equals to 4 minus 2i, and therefore u plus conjugate of v, that would be equal to -2 plus 3i plus 4 minus 2i. And that will give us 2 minus i. That's right, 2 plus i. Yes, sorry, 2 plus i. So therefore, to find 2 plus i, we need to go to 2 on the real axis and 1 on the imaginary axis, which is right here, and that will be our w. Okay, and this is just an achieve level question here. Achieve level question. And question B. Write 6 divided by 3 minus square root of 7 in the form a plus b square root of 7. So in this case, we're going to rationalize the denominator. So to rationalize the denominator, we need to multiply by the conjugate, okay? So we're going to say that 6 over 3 minus root 7 times of 3 plus root 7, because over 3 plus 3 plus root 7. Okay, so this will give us 18 plus 6 root of 7 divided by 3 times 3 is 9 minus root 7 times root 7, which is minus 7. This gives us 18 plus 6 root of 7 over 2. And that actually gives us 9 plus 3 root 7. That's our final answer for this question, and another achieved question here. One solution of the equation z cubed plus az squared plus 34z minus 40 equals to 0 is z equals to 3 plus i. If a is a real number, find the value of a and the other two solutions of the equation. So if z is a solution, by the conjugate root theorem, we know that the conjugate of z must also be a solution. So if 3 plus i is a solution, 3 minus i must also be a solution. And that's the conjugate root theorem. Alright, so let's just write down our roots here. So we have z cubed, so we have z minus 3 minus I of z minus 3 plus I multiplied by z plus c, we don't know, and that's equal to z cubed plus az squared plus 34z minus 40. Okay, so now we can just expand this. Okay, so z minus 3 plus I, z minus 3 plus I multiplied by z minus 3 minus I plus z plus of c equals to everything on the right hand side. Okay, so the good thing about the conjugate root theorem is that if you multiply by the conjugate, then there's no imaginary terms. So in this case, you can just simply look at this as z squared. Okay, so z times of -3 is minus 3z. Z times of I is negative zi, but it's an imaginary term, so we do not have to worry about it. So moving on to -3, -3 times of z is negative 3z. -3 times -3 is plus 9. -3 times -I is 3i, but it's an imaginary term, we forget about it. Moving on to be I, so I times z is imaginary, we can forget about it. I times of negative 3 is negative 3i. We can also forget about it. So I times negative I is negative I squared, which is plus of 1. And then we need to multiply by z plus of c. So therefore, if we simplify this, we get z squared minus 6z plus of 10 multiplied by z plus of c. And now we're going to expand this. We'll get z cubed plus plus cz squared minus 6z squared minus 6cz plus 10z plus 10c. Alright, as you can see here, in this term we have this 10c here, and that's corresponding to this negative 40 here, because it's the only one it's independent of x. It's the only term that's independent of x. Therefore, 10c equals to negative 40, c equals to negative 4. So therefore, we actually have here a z cubed minus 4z squared minus 6z squared. Negative 6 times negative 4 is plus 24z plus 10z plus minus 40. So we actually have z cubed minus 10z squared plus 34z minus 40. And that's our final answer. And our third root, negative 4, so therefore our third root would be 4. And that's all we need for this question, okay? This question is a merit level question. So in terms of our a value, okay, so our a value was actually negative 10 here. So a equals to negative 10. I forgot to state that, but a is negative 10. C is negative 4. Third root is 4. Second root is 3 minus I. And all of those will get you a merit grade. To get an achieved grade, you're looking at just the correct value of a. So just the correct value of a here will get you an achieved. Okay, if z equals to 15 over 1 minus 2i, find the modulus of z. Okay, first things first, we need to multiply by the conjugate in order to get rid of the imaginary part in the denominator. So 15 over 1 minus 2i times 1 plus 2i over 1 plus 2i. This gives us 15 plus 30i over, so 1 times 1 is 1, negative 2i times 2i is negative 4i squared, which is positive 4. 1 plus 4 is 5. So this will give us 3 plus 6i minus 2i, don't forget. Okay, so what we have here is z equals to 3 plus 4i. We need to find the modulus of z. So the modulus of z, that is equal to square root of x squared plus y squared. That's because the modulus is referring to the distance from the origin. If you look at the Argon diagram, we have 3, 4 here. So the modulus of z is simply referring to this distance from the origin. So we know that the x value here is 3 and the y value here is 4. So we can just do a simple Pythagoras theorem here. So modulus of z equals to 3 squared plus 4 squared, and that equals to 5. So therefore our modulus of z equals to 5. Therefore that is our final answer. And that's another merit question here. To get an achieved question, we need to have a correct expression with real denominator. So if we can get up to here, that was an achieved grade. Right, so question E. The complex number of u plus 3mi is on the locus of points defined by z minus 8 equals to z minus 4 plus 2i. Okay, for this question, we know z is a complex number, so we're going to say that let z be x plus iy. So we're going to have that x plus iy minus 8 equals to x plus iy minus 4 plus 2i. Now we can group the real terms together and the imaginary terms together. So x minus 8 goes together, plus yi equals to x minus 4 goes together, and plus of y plus 2i goes together. Okay, so modulus, like I just explained, would be the distance from the origin. So therefore, that would be square root of x squared plus y squared. So therefore, this will be x minus 8 squared plus y squared. That equals to square root of x minus 4 squared plus y plus 2 squared. And if we take the square of both sides, we'll get x minus 8 squared plus y squared equals to x minus 4 squared plus y plus 2 squared. Alright, so now we're going to expand on both sides. So x squared minus 16x plus 64 plus y squared. That equals to x squared minus 8x plus 16 plus y squared plus 4y plus 4. Alright, so x squared and x squared cancel out. y squared and y squared cancel out. So we have negative 16x plus 64. That equals to negative 8x plus 4y plus 20. Okay, so what we're going to do here, we're going to move the negative 8x to our side. So we have negative 8x on this side plus 64 equals to 4y plus 20. So therefore, we're going to move the 20 to the other side. So negative 8x plus 44 equals to 4y. Therefore, divide on 4 on both sides. We get negative 2x plus 11 equals to y. And we know that the complex number of u equals to 3 plus mi's on the locus. So if we know the Argon diagram, that's our real part, so that's our x-coordinate, and m will be our y-coordinate. So therefore, if we substitute x equals to 3 into this locus, we will find our mi. So y of 3 equals to negative 2 times of 3 plus 11. That equals to 5. So therefore, the value of m equals to 5. And the reason for this is because if we draw a graph here, okay, so our graph will look something like this. So any point along the graph here will satisfy this locus of points. So this equation will be satisfied if a point lies on this locus, which is a straight line here. So we know that the point of 3 plus mi is on this locus, but 3 refers on the Eigen diagram. This is the real part of z, this is the imaginary part. We know that the real part is occupying the x-coordinate, so we substitute x equals to 3 into our locus to find our imaginary part. And that's our final answer, m equals to 5. And that is an excellence level question. Okay, so you can go up to here as an excellence level question. To get a merit grade, you need the correct locus. Okay, correct locus. So that is your y equals to negative 2x plus 11. That's a merit grade. To get an achieved grade, you need an equation equating the moduli without absolute value signs. So third line. Getting up to here will get you an achieved. Question 3. U equals to 3 minus 2i and v equals to 2 plus bi. Find the value of b if uv equals to 14 plus 8i. Okay, so let's just multiply these two complex numbers together. So uv equals to 2 minus i times 2 plus bi, and that equals to 6 plus 3bi minus 4i. And 2i times negative 2i times bi is negative 2bi squared, which becomes plus 2b. To know that the real part of uv equals to the real part of uv, and the imaginary part of uv equals to the imaginary part of uv, okay? So therefore we're going to say that 6 plus 2b, that's our real part, that's equal to 2. And we're going to say that the imaginary part, 3b minus 4, that equals to, and that equals to b, okay? That's, that equals to 8, my bad. That equals to, this is 14, this is 14, and this equals to 8. Alright, so now we just need to solve the simultaneous equations. Multiply this equation by 2. Multiply this equation by 3, because the lowest common denominator with 3 and 2b and 3b, the lowest common denominator is 6. Times this by 3, times this by 2. 18 plus 6b equals to 14 times of 3, which is 42. So 6b minus 8 equals to 16. Okay, so now we're going to subtract the two equations. So we have 18 plus 6b equals to 42 minus negative 8 plus 6b equals to 16. So negative makes a negative, so that's 26. That equals to... Okay, sorry. Just forget I said anything. I am being really stupid. Okay. So for this question, you can actually just use any of one of these equations to solve because you only have one variable. I have no idea what I'm doing. I apologize for what I'm just doing. Okay, so 3b minus 4 equals to 8. 3b equals to 12. b therefore equals to 4. And that's our final answer. That is an achieved level question. Question 2, question B. Solve the equation x squared minus 6px plus 4p squared for x in terms of p, expressing the solution in its simplest form. So we're going to solve the equation. So that's your x equals to negative b plus or minus b squared minus 4ac over 2a. So x equals to 6p plus or minus square root of 36p squared minus 4 times of a times of 4p squared, all divided by 2. So x equals to 3p plus or minus square root of 36p squared minus 16p squared over 2. So x equals to 3p plus or minus square root of 16p squared over 2. X equals to 3p plus or minus 4p over 2. X equals to 3p plus or minus 2p. And that's our final answer. I make a mistake. So 6p, so 36p squared minus 16. Oh, sorry, my bad. This is 20p squared. Apologize. 20p squared. Okay. Apologize. Okay, so x equals to 3p plus or minus 2p root 5 over 2, because root 20, that equals to root 4 times 5. So therefore root 4 equals to 2, so this equals to 2 root of 5, and root of p squared equals to p. Okay, so those are the rules. So x equals to 3p plus or minus p root of 5. That's our final answer, and that's an achieved grade if you can get up to there. Solve the equation z cubed equals to negative k to the power 6 times of I. Okay, so first things first, whenever you see one of these questions, I urge of you to draw the Argon. Okay, red pen. I urge of you to draw the Argon diagram because you need a better visualization of where this complex number is. We know k is real and it's positive, so a positive number to the power of 6 is still positive, and negative a positive number is negative. So this is a negative I. So negative I is going to be lying somewhere here, you know. So this is the imaginary part, this is the real part. So therefore negative I will lie below here, will be lying here. So this will be our k to the power of 6 here. Alright, so we know that the argument, so that's our argument of z cubed, that is equal to this angle here, which is negative pi over 2. Alright, so now that we have everything in parts, we can actually say that z cubed equals to k to the power of 6, because that's the modulus, that's the length of this line here. Cis of pi over 2, negative pi over 2. And therefore z is equal to, so when you take the cube root of k to the power 6, cube root is k to the power 2. Cis of the angle gets divided by the power, which is 3. So negative pi over 2 divided by 3 is negative pi to the power negative pi over 6. So that's our first solution. Our second solution is our modulus stays the same, and our angle is added. So for this is a 3, so z to the power 3. So our one full revolution equals to 2 pi. So therefore one part of z will just be 2 pi over n, but n is equal to 3 in this case, so that's 2 pi over 3. So in this case it will be negative pi over 6 plus 2 pi over 3. z2 equals to k squared cis of what is this? Okay, so that's negative pi over 6 plus 4 pi over 6, so that's 3 pi over 6, so that's pi over 2. Z cubed, sorry, not z cubed. The third solution is k squared cis of pi over 2 plus 2 pi over 3. Z3 equals to k squared cis of 7 pi over 6, but this will be somewhere here because this angle is 7 pi over 6, so it's better if we write it as a negative because that will give us a smaller argument there. So we just need to subtract 2 pi. So if we subtract 2 pi, we should get that z3, the third root, is equal to k squared cis of negative 5 pi over 6. And that's our 3 solutions there. Okay, so for this question, that is actually a merit level question if you can get all 3 solutions. To get an achieved grade, you're looking at one correct solution. Okay, so either Z1, Z2, or Z3 will get you an achieved. Question D. Find the complex number W in the form x plus iy if the argument of W is pi over 4 and the W times the conjugate of W is 20. Okay, so we'll just say let W be a plus bi, so therefore the conjugate of W equals to a minus bi. Okay, so we have our a, a plus bi multiplied by our a minus bi, modulus of this equals to 20. So therefore we're going to expand. So therefore, what am I doing? Okay, so 20 equals to modulus of a squared minus abi plus abi. So bi times negative bi is negative b squared I squared, which becomes b squared. So 20 equals to the modulus of a squared plus b squared. Okay, so this is interesting. So we have the modulus of a squared plus b squared. So therefore, 20 equals to square root of a squared plus of b squared. Okay, so wait, sorry, what am I doing? 20 equals to modulus of a squared plus b squared. Okay, I apologize for what I'm doing. Okay, so this is actually all real. So this number here, so a squared plus b squared, is actually somewhere here on the real plane. Okay, so the modulus of this will just be equal to a squared plus b squared simply, okay? So this 20 equals to a squared plus of b squared. And the argument of w equals to pi over 4. So that means that the complex number is somewhere here. So that's when this is pi over 4. So therefore, tan of pi over 4 is equal to the y over... sorry, wrong one. So over x. So tan pi over 4 equals to y over x. Therefore, tan pi over 4 is 1, so y equals to the x. So, real part of w equals to imaginary part of w. Okay, so in this case, we can clearly see that our w is a plus bi. Our imaginary part is equal to our real part, a equals to b. Therefore, we have 20 equals to, we can just say 2a squared. So therefore, a squared equals to 10, a equals to root 10, and therefore, b also equals to root 10. So therefore, w equals to root 10 plus root 10i. That is our final answer for this question. This is a merit level question. To get an achieve level question, you're looking at a correct expression for the conjugate of w times w, which is all the way for here. So you can go up to here, you get an achieved. Okay, last question here. So what do we have here? We have square root of x plus k plus square root of x minus k over square root of x plus k minus square root of x minus k equals to 4. So we can just start off with moving the denominator to the other side. So x plus of k plus of square root of x minus k equals to 4 times of square root of x plus of k minus square root of x minus k. Alright, so square root of x plus of k plus square root of x minus k equals to 4 times of square root of x plus of k minus 4 square root of x minus 4 times square root of x minus k. So because these have like terms, if we move it to the other side, we can clearly see that 3 square root of x plus of k, that equals to 5 square root of x minus k. Yes, okay. Now we're going to square both sides, so 9 times of x plus of k, that equals to 25 times of x minus k. Okay, so we can move the 9 to the other side, so x plus of k equals to 25 over 9. That equals to 25 over 9 times of x minus k. So therefore, x plus of k, that equals to 25 over 9x minus 25 over 9k. And we want x in terms of k, so we want x to be the subject, so x plus of 25 over 9, minus x minus 25 over 9x, that equals to negative 25 over 9k minus k. Okay, so for this, we're just going to factorize for like term, which is x. So x1 minus 25 over 9, that equals to negative 25 over 9k minus k. So therefore, 1 minus 25 over 9, what is that? That gives us negative 16 over 9x, that equals to negative 25 over 9. That equals to, we can actually factorize the k as well, so negative 25 over 9 minus 1. So negative 25 over 9 minus 1, that gives us negative 34 over 9, so negative 16 over 9x equals to negative 34 over 9k. So x in terms of k, so we're going to make x the subject, so x equals to negative 34 over 9k times of 19 over 16 negative. Alright, so x equals to 17 over 8k. That should be our final answer for this question. 17 over 8. So x equals to 17k over 8. That is our final answer. That is the correct answer. This will get us an excellence grade. To get a merit grade. Okay, so I think NCA did a completely different way to me, but in terms of a merit grade, I reckon if you can perhaps make it up to this step, I reckon you can get a merit grade. To get an achieved grade, if you can just get up to here, I reckon you can get an achieved. Okay, so thank you for watching this video for the 2018 Level 3 Complex Numbers. I hope you enjoyed, and I hope to see you all in